Example problem 5. Writing a rule to describe a pattern. You can use words or an algebraic expression to write a mathematical rule that describes a real-life pattern. Hobbies. The table below shows how the height above the floor of a house of cards depends on the number of levels. Part A asks, what is a rule for the height? Give the rule in words and as an algebraic expression. All right, so take note of the image shown here. We have a table height of 24 inches, and that is where the card house is being built from. Each level of the card house looks to be 3.5 inches, so that would be the length of each individual card. And then we have a nice table. Here at the left, we have the number of levels and the height represented in each of these two columns. Note when there are two levels of the card house, we use the expression at the right, 3.5 times 2 plus 24. Take careful note where each of those three terms, or in this case three numbers, have come from. When there are three levels, 3.5 times 3, that quantity plus 24. Four levels? The question is, when there are n levels, so now for some arbitrary value n, it could be 29, it could be 33, it could be 987. We want to be able to write an expression that represents any level n of the card house and reveals to us its height. So we'll have a variable in place, but when substituting in a number for that variable, we could find the height of the card house. So let's consider where the number of levels was inserted into each of the expressions at the right. Well, 3.5 was in place as the first of two terms in our parentheses, and that was 3.5 times 2, times 3, times 4. Note those were the number of levels. So for us in this case, our expression will be 3.5 times n, and then we have to add or sum that value with the height of the tabletop, 24. And of course, I've left out our inches, our units, but we'll recall that we're dealing with inches. Now, to write this a little bit more simply, 3.5 times n doesn't need to be written in parentheses, nor does it need to have a multiplication dot in place. So let's write that as 3.5 n plus 24. Part B. A group of students built another house of cards that had 10 levels. Each card was 4 inches tall, and the height from the floor to the top of the house of cards was 70 inches. How tall would the house of cards be if they built an 11th level? The house of cards is currently 70 inches tall, so we would be adding 4 to that, or getting 74 inches height. And that's if the 11th level were added. And if that's at all difficult to visualize, consider this. Quickly sketch a tabletop. I'm not even going to try for 3 dimensions. And we have a card house being built on top. Currently, the card house has a height of 70 inches off the ground, and the question is, if an 11th level were added, or one more level were added to the current 10 levels, cards being 4 inches tall, what would the new height be? Well, each card being 4 inches tall means that we would simply add those two, 70 and 4, to arrive at a 74-inch top of the card house. Part C. Another group of students built a third house of cards with n levels. Each card was 5 inches tall, and the height from the floor to the top of the house of cards was 34 plus 5n inches. How tall would the house of cards be if the group added one more level of cards? Well, consider carefully 34 plus 5n and determine what each of these terms represents. 34 plus 5n. We know that n represents the number of levels of the card house. We know that each card is 5 inches tall, so 5n will represent the total height of cards in the card house. 34 must then represent the height of the base of the card house off the floor potentially the tabletop upon which the house is being built. And the question is, if one more level was added, well, instead of having 5 levels, we would now have 6 levels. So rather than 34 plus 5n, we would have an expression 34. Tabletop height hasn't changed. Plus 6n, 6 levels rather than 5. And a chance to show that you have got it. Suppose you draw a segment from any one vertex of a regular polygon to the other vertices. A sample for a regular hexagon is shown. Use the table to find a pattern. Take note in the table we have the triangles and polygons. The number of sides of a polygon, 4, 5, 6, and finally n, and the number of triangles, 4 minus 2, 5 minus 2, 6 minus 2, and an unknown expression. Work carefully and make your selection from the choices below.